Okay, this lesson is for Wednesday, January 25th, 2012. Today you're going to be working on a Harmonic Motion Lab. You'll be using Logger Pro software. You're each going to have access to a laptop. So let's go ahead and talk about what you're going to do on the laptop. The first thing is when you walk in, you should have received a worksheet. And if you have a mobile device, you can actually access this lab on that. And the PDF file here, we're going to start with the Harmonic Motion Lab, is going to be the first to open up Logger Pro, and it walks you through the directions on your paper, and you can go ahead and follow along with me as I go through the actual lab right now with you. Okay, so when you open up the Logger Pro software, you'd have to open up the Simple Harmonic Motion Lab, and here you'll see that there's an actual video of a person holding a weight, and when he releases the weight, it's attached to a spring, and that spring bounces the weight up and down. This is an example of harmonic motion because the object is repeating its motion, and we can actually calculate, the period, frequency for this motion, and actually plot that out. We can calculate the amplitude of how high the wave is going and that sort of thing to calculate how much energy is there. So to actually start using this information, let's go ahead and start by going through what you're doing on your worksheet. The first thing you need to do is enable this video analysis here. And when we enable that, it actually pulls up a chart. Okay, so if we look at this chart right now, the first thing that they tell you to do is going to be to make some points. But to do that, we actually have to get this video till right before the person lets go of the weight. So I'm going to play the video, and then I'm going to stop it about where he let go, and I'm going to backtrack, and you'll see his hands coming back into the picture. And I'm going to stop it right as he lets go of it, right here. So at this point, I'll go ahead and start putting in my points, adding them. One thing that's important is you can enlarge this video and shrink it, and because it's so small here, it's a little bit hard to see, so we'll enlarge it. And what we're going to be doing is we're going to be putting points at the bottom of this weight. So we'll go ahead and put a point here at the bottom of the weight, and you'll see that it kind of advanced on the screen, and it also placed a point over here. It placed 2 points over here on my graph. So I'm going to continue to do this. I'm going to put a point at the very bottom of the weight each time. You'll notice that vertically I'm keeping my points pretty much in line with each other. So we're going to do this for 5 cycles, which means that the weight should go down and back up 5 times. So I'm going to go a little bit faster here. Let's take a look and make sure I got 5. So that's 1, 2, 3, 4. Got to do one more. Okay, so you can see that I've already placed these dots, these points, plotted them, and we can go ahead and look over here at the graph and see what we've got here. Okay, you'll notice that the numbers, first of all, are not very accurate. It's saying up to 240. Well, 240 what? Is that 240 centimeters? What we have to do here is actually create a scale on this video so that the software knows what scale we're working with. And in this case, this is 1/2 meter high, so we'll go ahead and pick a point right here. We're going to say it's 1/2 meter from the motion detector up to the top point. And we're going to set that scale as 0.5 meters. The units here are m for meters. Okay, at that point, we need to do one more thing to make sure that this graph is showing us the accurate height away from the motion detector. We're going to set an origin by clicking this button right here on the video analysis and we're going to set that origin right at the bottom of the green line. Okay, now one thing we have to do on our graph to set up our data, you'll notice we have this nice wave formed to show the harmonic motion of the weight. We're going to get rid of these x values by clicking over here on the y scale. And the x values aren't important to us because this weight didn't move left and right on the x-axis. Instead, it was moving up and down on the y-axis, so its y position was changing. So we're going to go ahead and change this so it doesn't show x values and just click so it only shows y values. And now we've got this nice little graph where we can see the motion of this wave. Now, the interesting thing here is that you can see the fact that it's measuring time here allows you to find the period of the wave, and it also allows you to find the amplitude of the wave. You can see where the midpoint is at about 0.45, and you can see that it gets up to about 0.5, and it goes down to about 0.4. But all of this can be analyzed from your graph, and that's going to be the important part of your worksheet. You're asked to, at the very end of all this, when you're done making your graph, to actually make some calculations for period, frequency, and amplitude of the wave that you just created. And it's really important you explain how you got that. Please don't just put numbers. Explain where you're looking on the graph to get this information and how you went about setting that up. Okay, that's going to conclude the lab for today. It's really important that you do your best on it. If you have questions, by all means, make sure you handle those before you leave. One thing I wanted to show you also before you left is this is how you can plot the data manually, but there is a way to actually plot it on these graphs that have been given to you. If we actually start it here, you'll see that it'll plot the motion of the slinky as it goes throughout, so you can actually measure it that way as well. Alright, so that's everything for Wednesday. Make sure you get this lab turned in before you leave.